Cool, thanks Lynn. And welcome to FroZug. This is the first time I've been here. I'm Brendan Gregg. And tonight I've been asked to give a performance talk. I'm actually here in Colorado teaching a performance class that I wrote. So performance is very much on my mind right now. And I've also been, of course, I'm always working on performance analysis. So this talk, someone suggested the title Little Shop of Performance Horrors because we're near Halloween in the US. So sounds good to me. I usually give talks on how to perform performance analysis, cool performance analysis technologies, and awesome benchmark results. I've given lots and lots of talks. I've reached the point where I like to give different talks, partly for my own amusement as much as yours. And with the title Little Shop of Performance Horrors, I thought it'd be great to give a talk entirely about things going wrong. So nothing in this talk is good. This is all about things going wrong, what mistakes we've made. I actually think it's a very useful way that we learn and how we develop experience with various topics is learning from our mistakes. It's a complicated thing to talk about. It's a tricky thing to talk about. I can't, on the screen, go through the worst performance mistakes various customers of Sun have made because the customers won't like that very much. So I have to be careful about what I do talk about. Things that are public are easy, like the bugs in OpenSolaris and the bug database. So I can understand why people don't do this that much, talk about mistakes, but I want to have a crack at it because it's useful. Each of them provides lessons that we can learn from. This is not just 1 or 2 hours of misery. This is 1 or 2 hours of small, discrete lessons. Don't make these mistakes because I've made them. So what I want to talk about is the worst performance issues I've ever seen. And there's just a couple that really spring to mind that take the cake. They're public. Fortunately, they're far worse than anything any customer has done. Common misconfigurations. There are still many out there, and it's useful to iterate over them. The Encyclopedia of Poor Assumptions. I'd like to spend some more time filling this out, but with performance analysis, there are a lot of assumptions people make that aren't quite right, and you'll get to see that. Unbelievably bad performance analysis. I've got one example there that is actually pretty common. Death by complexity, bad benchmarking, misleading analysis tools, of which there are many, some insane performance tuning, of which I was doing some this week, and the curse of the unexpected. So I thought about what topics encapsulate all the bad areas of performance. And I think this is the set. So the worst performance issues I've ever seen. Anyone remember SMC, the Solaris Management Console? In Solaris 9, this thing took a while to boot. If you had just freshly installed a server and then fired up SMC, it could take half an hour to boot, 30 minutes. What was it doing that whole time? So as it turns out, it was doing 12 million mostly 1-byte sequential reads of a 72 kilobyte file. So I've seen in textbooks, people try and teach tools like truss and dtrace by saying, for example, a classic performance issue would be an application that does 1-byte reads. Of course, no one would actually do that. It's like, well, actually, we have done that. SMC does. This doesn't have to be a theoretical example. This is a real example. 12 million mostly 1-byte sequential reads. During startup, it fired 7.7 thousand processes. Mostly they're sed and awk and shell, which you could replace with, say, Perl. Over 9,000 disk events, 2,000 of them writes to that 72 kilobyte registry.surf file. So a textbook example of something going wrong. The analysis was performed using dtrace. Who in the room has used dtrace? Hooray, lots of people. So if you haven't played with dtrace, my instinct is to give you the the previous performance talks I've given, awesome performance tools, but I'm going to try and stick to things that are bad. But dtrace is very cool, and you can examine things very easily. The SMC issues were identified with syscall frequency counts and syscall arguments. dtrace lets you look at the whole stack. I can look inside the kernel, I can look inside Java code, which is what the SMC is written in. So the 30 minutes of latency is really ripe for the taking. It's got to be somewhere, and dtrace can find it. So I don't really need to stick to traditional system calls. I could be more fancy and go through Java and go through anything. But they just worked. Why they probably haven't been found before would be due in part to the 7.7 thousand processes executed. So to do syscall analysis previously, one of the best tools is Trust for it. And of course, I'm a dtrace guy, but Trust does have some benefits. It's simple to run. It gives you nice translations of arguments. But Trust only runs on one process at a time. So one of the advantages about dtrace is it can dtrace any process on the system, and especially if you have 7.7 thousand of them, it can gather information as they're executing and ending. So that's probably why this is so easy to pick with dtrace. Very much low-hanging fruit. A lesson from this, these aren't just tales of woe so that we all feel depressed. Examine high-level events wherever possible. One of the big problems in performance analysis is people assume that they know what's going on. They don't look at the easy stuff. If I'm looking at a server and it's processing NFS traffic, what files are being accessed? It's pretty simple. What clients are accessing my NFS server? A lot of people try and dive down the deep end and look for tunables, look for, let's tune the number of mount D threads, let's tune the mount options. Start with the big stuff. What are the highest level events? And syscalls are really a high level event. The interface between userland and the kernel, how the userland asks the kernel to perform tasks. It's a very useful high level event to have a look at. So even though of course I can do dtrace at any layer of the stack, I do spend a lot of time looking at system calls because they're easy and they are the high level events. Another of the worst performance issues I've ever seen. Has anyone used the NXG device driver? So one person admits to it. I can talk about this because it is public, this information. In fact, if you're interested in my SMC dtrace analysis, I did that before I joined Sun recently, and I wrote this is when dtrace was new and no one knew what it was. I actually wrote a website on it and showed how I detraced SMC. So, and that was a pathologically bad application at the time. I didn't mention, but I should. There is a happy ending. Performance did get a lot better when they shipped Solaris 10 properly. So don't think that SMC is terribly bad now. Have a second look at it. And dtrace certainly helped. NXGE is Sun's 10 gigabit network device driver. I was involved in a lot of testing during product development, and NXGE really had some of the worst performance problems I've ever seen, which we fixed. So don't feel bad about using NXGE. We identified these in product development before the products were shipped to customers. So, like I said, it's tricky to talk about performance issues, but disclaimer, you shouldn't be running into these issues because we found and fixed them.